Hello everyone, let's solve the problem network topology, this one here, and you can read the entire problem. They have clearly mentioned the problem along with the diagram. So also they have given the input and output. So they have mentioned the example as well, here examples as well with the input and the what has to be the desired output they have given here. So I'll just summarize this problem for you so that it is very easy to understand. So just give me a second. So yeah, what the question states. So we have a connected undirected graph. So we have connected undirected graph. This is not the directed graph. We have the connected undirected graph representing a computer network. So this represents the computer networks, right? So with n computers and m cables, two things. That is, one thing is m computers and n cables. We can just take this one, n computers and n cables, right? So we have a group of, we have undirected graph with a computer network of m computers and n cables. So what we need to determine? We need to determine the type of network topology. It represents from three possible types. We need to mainly, in simple terms, we need to determine the topology, network topology that it represents. So what kind of network topology that it represents, that we need to determine from either three of the possible types. One is bus topology. I'll just give BT, bus topology. Second one is this one, ring topology. And third one is this one, star topology. So these, out of these three things, we need to determine which topology it belongs to, right? If the topology doesn't fit any of this, then we should return unknown topology. So we have to return unknown topology. I'll just give UT here. If the topology doesn't fit into any of the three types, nothing but bus topology, ring topology, or the star topology, we have to return this one. What do you call? This unknown topology. That's what they have given in the question. So I hope this question is clear. So what I'll do next, let's start discussing the approach, right? So first we'll be going with the first step, we'll be going with the input reading as always. So I'll just skip this one. When we write the code, you'll get to know this one. This is almost similar for most of the problems. So next step after input reading, so this is mainly this belongs to the JavaScript side or the Node side, right? So while writing the code, you'll get to know this properly. Next is, we have to understand the graph topology, right? Bus topology is nothing but the graph is a path where two nodes have a degree of 1 and all other nodes have a degree 2. So just give me a second over here. So they have just given this one diagram, right? So I'll just tell this one. So you'll get to know what is bus topology, ring topology, and star topology. So first step was input reading. Second step is understanding the, let me explain this one. So bus topology is nothing but a graph, that is, the graph is a path where two nodes have degree 1. Two nodes should have degree 1 and all other nodes should have degree 2, right? So two nodes should have degree 1 and all other nodes should have degree 2. This is bus topology. So what is ring topology? Each node is connected to exactly two other nodes. Each node is connected to exactly two other nodes. That is ring topology, right? So here, this is ring topology. Each node is connected to exactly two other nodes. That is ring topology. Star topology is nothing but one central node is connected to all the nodes. So there will be one central node and it has to be connected to all other nodes which have a degree of 1, right? We'll be having the degree of 1 and the central node has the degree n minus 1. So I hope this is clear. What is bus topology and ring topology as well as star topology. This is the second step. So after, let's move to the third step. Let's check the graph conditions. So what we need to do, let's count the degree of each node. We have to count the degree of each node. Suppose we have A, B, and C. Also, let me give D here. Suppose we have this one. We are counting the degree of each node, and we will be checking number of edges m and compare it with the number of nodes n to decide which topology according to this condition, whether it is a bus topology, ring topology, or the star topology that I explained in the second step, right? According to the condition, we will be going with this step. Basically, based on, we'll count the degrees of each node first, then we'll check the number of edges m and we'll compare it with the number of nodes n to decide which topology it might be. So let's convert this one to the code. So while writing the code, you'll get to know clearly. So let's start by importing the fs module to read the input data as usual. So I'll just give fs equals, let me give the require fs. So after this, we have to read the entire input from stdin, right? Also, we have to split by new lines to read each input line, and also we have to trim trim all the white spaces, because to differentiate the character or the number, to differentiate between the character, distinct character or numbers. So in this case, I'll just give let input equals fs dot read file sync of 0, comma, we'll set this one, set encoding to UTF-8. So we have to trim all the white spaces, right? To distinguish between, to distinguish between different inputs in the same line. Also, we have to split to read individual lines. So in my case, I'll just make use of the regular expression. So this will be easy. Just give me a second. I should have copied this one basically. Let me give slash over here. Let me remove this one. No need of single inverted comma. So I'll just come here. So yeah, this is it. Next, after doing this, let's initialize the counter to process the input lines. We'll be starting with the zeroth line, first line, right? That one will be initializing with the 0. After initializing, we will be reading every input, every line, right? Each individual line. So for initializing, I'll just give let count equals 0. Also, let read num. I'll just give here. Just take this input of count plus. So if you have followed the dynamic programming playlist, then you would be knowing what I'm doing here. So input handling is almost same for most of the problems. So again, here I'll just leave the space to distinguish between the numbers, right? Or the string. So map, I'll just take A of plus 8 over here. So this is fine. Next, let's read the number of nodes and edges. We have to read the number of nodes and edges, right? So for that, I'll just consider the destructuring operator. You can consider each variable name and assign this one, read now. I'll just consider the destructuring operator. It will be easy, right? So again, after this, let's create the array to store the degree of each node. Let degrees, I'll just make use of viewing 32 array. So this would be of 32-bit, right? So this is memory efficient. You can make use of in that format, array format as well. Like you can just give new array of size something and fill that one array initially with 0 or -1. you can make use of array. You can create array in that format as well. I'll just be making use of uint32 array. So this is the reason why I am using this one is because this is memory efficient, right? So that is the reason I'll be using this. So next, let's initialize an array to store the edges. Nothing but I'll just give edges equals empty bracket. So next, let's process each edge and update node degrees. Nothing but after initialization, we'll be going with the iteration, right? In simple terms. So what we are doing here, if we need to understand correctly, we are just processing each edge and we are updating the node degrees. For that, let's iterate. For let I equals 0, I, then m, and this has to be I less plus. Also, let hex comma y, let's make use of the destructuring operator. And what we are doing in this step is we are just reading the nodes that is connected by the edge. So basically, I'll just make use of x and y. We have to read, right? For read, I'll just make use of read num. This is fine. Next, let's increment the degree of each connected node. So I can just write in this way, degrees x minus 1. Let's increment this one. Also, degrees, this has to be y minus 1. X and y we have made use of, right? This has to be x and y. Also, after incrementing the degree of each connected node, we have to store the edge somewhere. So we'll not be using further in this code, right? So we have to store this one somewhere. So for that one, I'll just be making use of push. So for the edges, I'll just give edges dot push to store it in the array. So I can just give, we have to store this one in the array. So I'll be making use of the array and I'll just give x comma y. So I hope this is clear till here. Next, after this, we have to check if the graph has exactly n minus 1 edges. Nothing but if it has exactly n minus 1 edges, then either it will be a bus or the star topology. So for this is just a condition, right? We can directly make use of if condition. If n equals n minus 1, then we can directly write let count 1. I'll just set this one to 0. Also count 2. I'll just set this one to 0. So these naming conventions are easy to understand. So after this, let's count how many nodes have degree 1 and how many nodes have degree 2. For that, so after the initialization, as usual, we'll be going with the iteration. So I'll just give 0, I less than m, I less plus. So if degrees, iterated value of the degrees, if it is equal to 1, then we will give count 1 plus plus. So we are incrementing the count 1. Same goes with this one. If the iterated value of the degrees is equal to 2, then we'll increment the count 2, right? So I'll just copy paste and make the necessary changes instead. So I'll just give me a second. This one I just has to be count 2, and here this has to be, this is fine. So after this step, what I'll do for bus topology, we should have exactly 2 nodes with degree 1 and rest with degree 2. While explaining the bus, star and ring topology, I did explain, right? So for the bus topology, we should have exactly 2 nodes with degree 1 and rest with degree 2. So again, I'll be making use of the if condition for this. I'll just give, this is simple, count 1 if it is equal to 2 and count 2, this is equal to n minus 2. Then what we will do, let me make use of, we have to print, this is bus topology, right? For printing, I'll just make use of console log. I'll just give within the string bus topology. So this is fine. We have to exit. So I'll just make use of process.exit of 0. So if it is bus topology, after this we have to exit, right? For that reason, I have just made use of the process.exit of 0. So I hope this is clear. Next step is we will check if the graph has exactly n edges. Nothing but we are checking for the ring topology over here. First we have checked for the bus topology. Then if we'll check if graph has exactly n edges. So nothing but ring topology. This I can just copy the same thing and make the necessary changes. But still this is fine. Let's type this first. If m equals n, then we will just give count to equals degrees. Let's make use of the filter. Sorry. Oh yeah, this one. Filter. And just take one random variable. D. This has to be equal to 2. Length 2, right? So I'll just make use of the length over here. We know that for ring topology, all the nodes should have the degree 2. So we have only one condition over here. So I'll just give count to. If this is equal to n, then let's make use of console log of ring topology. After this one, again I'll just make use of process.exit of 0. This is fine. Then after this, there is one last condition, nothing but for the star topology. So we'll check if the graph has exactly n minus 1 edges again. So it can be either star topology or bus topology, right? It is potential star topology. So again, I can just give here if m equals n minus 1. So in this case, let me give, it has to be center, right? The center one, let's again make use of the filter here. Decrease dot filter. Just take some random, this one, random character. D. We are checking if it is n minus 1, right? For the star topology, yeah, n minus 1 dot length. So this is fine. We are also going with the leaf count. So I'll just give leaf count. Again, we'll just make use of the filter. Degrees filter D. So we'll check if D equals 1, right? So length. So we know that why we are doing this. We know that for star topology, one central node with degree n minus 1 exists and n minus 1 nodes with degree 1. So for this, let's continue with the condition. So if center count, if it is equal to 1, center count has to be equal to 1, right? And leaf count that I have took here above this one has to be n minus 1. As I have explained, center count has to be 1, only one node, and leaf count has to be n minus 1. For this, I'll just make use of $& and leaf count I'll just give if it is equal to n minus 1. So then I'll just console log of let me give star. This is star topology, right? Let me give star topology. So this is fine. Again, let's make use of process.exit of 0. This is fine. After this, if there was one more criteria, right? There was one more criteria that if none of the above conditions match, or if none of the above conditions match, then the topology is we have to display unknown topology. For printing, I'll again make use of the console log. I'll just copy this one, console log. Should I copy the entire thing, entire line? It's fine. I'll just give unknown topology. So this is fine. This is it. Let's check with the input they have given. So for this, we have to get bus topology, right? I'll just paste it over here. Let me hit the run. So we are getting unknown topology, right? So we have to get bus topology. What's the wrong thing? Let's check what we have. So what mistake I have done here is in the line number 18. So here, right, this has to be bus topology, but we are getting the output unknown topology. So here I'm comparing n with n minus 1. So this has to be m, right? M has to be equal to n minus 1. So that's what we need to do. Again, we'll check for m equals n minus 1. Here, this is correct. M equals n and m equals n minus 1. So I hope this works this time. So now, yeah, we have, this is bus topology. We have the correct output, right? So this is fine. Second thing is I'll come here. Let me copy this one and paste it over here. This time this has to, and what happened? This.ter is not a function. Line number 33. So let me come here. Somewhere I have missed something. So what we have to use here, just give me a second. This has to be filter, right? We are filtering here. Why this has become ter? So yeah, filter. May run this again. So yeah, now this has to be ring topology, and yeah, we are getting ring topology. This one, let's copy this one. We have to get star topology, right? So let's check for this input. So we are getting star topology. Final one, for this input we have to get unknown topology. So it needs no, it doesn't meet the criteria. So we should get the output unknown topology. So let's check. Yeah, now this is working absolutely correct. Just give me a second. Just come here, submit code. Let me choose problem A, network topology. Let me hit the submit. So what happened? Oh, sorry, I didn't paste the code. So yeah, let me hit the submit code again. Let's wait for some time. So yeah, you can clearly see here, this code got accepted, right? So this code works absolutely correct. So I had made some typos basically. I don't know why I typed filter, but here I saw ter. That's fine. And here instead of I had given n for the bus topology, right? So these were some of the typos. That's fine. So now this code works absolutely fine. This is it. Thanks for watching, guys.